So here we are trying to find just some general information about this situation that's happening. We just have substance E starting in the liquid state at 0 degrees. The key thing is that they tell us that we transfer 0.01 joules per second, which then allows us to calculate all the different heat for the different at different times. So for example, if we go from 0 to 15, in fact, this is not joules per second, this is kilojoules per second. So if you multiply that, which makes this 10 joules per second. So for example, for the first 15 seconds, we add 150 joules. For the next 5 seconds, we add 50 joules. And then for the last 30 seconds, we add 30 joules of heat. That then allows us to do the different calculations we need to do. First of all, you can answer part B. Where is the question is, where is the temperature of the phase change? Remember, on these graphs, the phase change happens when it's at a flat line. So it'd be 65 degrees Celsius or 338 Kelvin. So that's your answer to part B. Remember, flat lines in these situations signify phase change. So let's go and calculate part A. Again, for A and D, we're going to use the MCAT formula. So Q equals MC delta T. But for each one, we're going to solve this for C. So it's just going to be simply the amount of heat that we added divided by the mass times the temperature change. So for part A, trying to find the specific heat in the liquid phase. So we added 150 joules of heat. They tell us that there's 0.35 kilograms. And the temperature change is 65 degrees. You can leave that in Celsius or Kelvin. Remember, a 1 degree change in Celsius is a 1 degree change in Kelvin. So for the liquid phase, the specific heat would be 6.59 joules per kilogram times Kelvin. So there's your answer to part A. Part B now focuses on, we answered part B. Part B was the temperature. Part C now looks at what is the latent heat at that for that particular situation. So that's just simply Q equals ML. All right, and then we solve it for L, that's Q over M. So we added 50 joules, and again, we have a 0.35 to find a latent heat of 143 joules per kilogram. And that's very typical that you'll see that number will be higher than the specific heat. It takes more heat to change the phase than it does to actually do a temperature change. Now part D, we have, again, we're finding specific heat. So again, we use the Q equals MCAT. Let's solve it for C, it's Q over M delta T. And for that 30 seconds, we're adding 300 joules of heat. Again, the big assumption in these questions is that we don't lose any mass. So now we just simply do 300 divided by 0.35 times 32, and we get a specific heat of 26.8 joules per kilogram times Kelvin. So there are your answers for this particular example.